Hello everyone, we are in team number 3 and I am the presenter Jessup Choi. We organized the Lotte World Tower into the following categories: foundation and concrete, structure frame design, among them outrigger, belt truss, and diagram, lifting system, and precise and safe construction. The foundation and overall frameworks that form the foundation of Lotte World Tower are made up of optimal materials. During the actual construction period of 7 years from 2010 to 2016, various construction work were carried out at Lotte World Tower. Various construction technologies and methods were applied for each construction. In order for such method and construction to be success, optimal materials must be used. Among them, steel and concrete, which form the foundation and the entire framework, are important parts. To ensure the rigidity of the highest building in Korea, steel bar of HT 500 was used, and it was used for the first time among skyscrapers in Korea. Due to the nature of high-rise construction, a massive amount of high-strength concrete is required. In such cases, it must be considered that thermal cracking caused by hardening high-strength concrete and spalling failure, in which water vapor inside the concrete explodes and destroys the high-strength concrete. Therefore, high-strength concrete mixed with special polyfiber was used in Lotte World Tower, and this polyfiber was the solution to spalling failure by creating smaller gaps. Next, let's take a look at the elements that form the foundation of Lotte World Tower. Before the foundation work, a precise ground survey was carried out, and it confirmed that ground was 2.8 times stronger than Burj Khalifa. For a more strong foundation, 108 concrete piles with a diameter of 1 meter and a length of 30 meters were installed on the lock layer to reinforce the ground more strongly. Then, on such a strong ground, the mat foundation work was carried out. On this ground, the 32,000 cubic meter mat foundation was completed through consecutive concrete casting for 32 hours to secure best durability and strength performance. 80,000 tons of concrete was used for this enormous mat foundation. In addition, a cut-off wall was constructed around the mat foundation to prevent the infiltration of groundwater on such a large foundation to ensure long-term durability and stability. The structure frames of Lotte World Tower were constructed on such a strong mat foundation. Then, let's take a look at the core wall and mega column that be constructed first among structure frame design. First of all, a sturdy core wall and 8 mega column, which act as the spine of the Lotte World Tower, were constructed. The core wall and mega column were gradually reduced as the floor height increased. This is because Lotte World Tower has adopted the taper type of skyscraper. This form is statistical strategy for skyscraper to control the effect of wind as it goes up to higher floors. These core walls and mega columns needed to ensure maximum strength through fast construction cycle. Thus, ACS was introduced completely, which could provide this fast construction cycle. ACS is a type of system formwork, does not require a separate lifting machinery, and can move the floor by itself through built-in hydraulic cylinder. The types of system forms are gang form, slip form, and ACS. Among these, ACS was most suitable for Lotte World Tower. For the reason, the introduction of tower crane must be needed for the attachment and detachment of formwork to the frame. And fast construction is impossible because the higher the floor is, the more the wind is affected in gang foam. Second is the slip foam. Slip foam, like ACS, is a formwork that can be raised automatically by hydraulic machine. The process cycle is so fast that it can be raised one floor per 1 or 2 days. Depending on the shape of Lotte Tower, where the frame gradually decreased, the slip foam was not able to automatically adjust the displacement and fix it to the wall. So the ACS was finally adopted. To respond to the gradually decreasing frame, ACS extends anchor unit automatically. It reduces the top surface of the frame by keeping the formwork straight. In addition, when the bottom of the ACS moves all the way to the reduced frame, the anchor is restored to its original state, and the climbing operation is repeated. Also, the scaffolding is automatically adjusted to the displacement. Because of these characteristics of ACS, core walls and mega columns could be built successfully. Then first of all, let's see how the outrigger and bell truss works. Then, between the low and high floors, outriggers and bell truss, which are connected to this core wall and mega columns, were constructed. This is a structure system that allows Lotte Tower to respond to lateral force. It adopted the core supported outrigger system. It is a system that connects the core wall and mega column with the framework of the building where the outrigger was constructed. As you can see, the outrigger is connected to the mega columns and core as follows. In this situation, if the lateral load is applied, the outrigger transmits the force to the connected mega columns and core to withstand it. As this outrigger was constructed, bell trusses were introduced for each section to surround the outside of the building. 8 mega columns on the outside are tied and unitized. Therefore, it helps efficiently transmit the lateral load to distributed frames. So, the lateral load is transmitted through outrigger and bell truss as follows. Lateral load, exterior columns axial force, outrigger bell truss, core wall, foundation. So, looking at Lotte Tower, bell truss and outrigger were applied to 107th floor as follows. And the diagram is constructed from the 107th floor to the top floor to resist the lateral load. By arranging the structure members diagonally, this diagram reduces material weight by 20% over the normal column and increased the efficiency of transmitting the load. When looking at the principle of loading of diagram, when wind force is applied, tensile and compressive force act to show resistance. And when axial force applied, the load is distributed through the member. Also, this diagram is connected with the bell truss on the 107th floor, the outrigger on the lower floor, and the bell truss to resist the axial force together. Through this process, Lotte Tower is equipped with wind-resistant and earthquake-resistant design that withstand wind a maximum instantaneous wind speed of 80 meters per second and an earthquake with a magnitude of 9. And after this frame construction were finished, the cotton wool was applied. Cotton wool method is a construction method in which the outer wall does not support the load of the building and acts as a curtain. So in fact, it is not technically a frame that supports loads. There are 3 main advantages of this cotton wool method. First, it is lighter than exterior building materials such as concrete, so that reducing the overall wind load and reducing the cost of structure. Second, it can shorten the construction period. Cotton wool exterior materials are pre-fabricated material from external factory so that it can be used in parallel with the framing construction. So it can also minimize temporary construction. Third, it improves aesthetic of the building. Since exterior walls are finished using materials such as glass and metal panels, a stylish appearance can be achieved. The unit wall method is adopted, which is made in advance in the factory and only needs to be installed on the site. So, additional work does not need in the site, which helps to reduce construction period. Therefore, it was applied to Lotte Tower. Lotte Tower's exterior is 21,000 units in total, and its weight is 600 kg per one unit. 17,000 cotton walls of different types of units were used. The glass of cotton wall at Lotte Tower was made as follows. Next, let's take a look at the lifting systems that are more important in high-rise construction. Let's find out about lifting system by classifying if it has tower crane, hoist, and pumping of concrete. First is tower crane. There are two main methods to construct a tower crane: is external climbing and internal climbing. External climbing is the method of increasing the height of the crane itself by continuously installing the additional mast as the frame lies. So the crane's weight continues to increase. Therefore, it is not appropriate to construct a skyscraper like Lotte Tower. Then, let's find out about the more appropriate method of internal climbing. Internal climbing is a method in which the tower crane is fixed to the building and climbed directly through the hydraulic machine. In the internal climbing method, a tower crane is first installed between the building frames. At this time, a collar and climbing rail and a hydraulic jack are installed. In this case, the weight of the tower crane does not increase because there is no need to continuously at the mast. Therefore, it is suitable for skyscraper. Next, let's find about hoist. Hoist is the lifting machinery that used to transport material such as concrete in construction site. Before explaining hoist, I will explain hoist common tower first. Hoist common tower is a steel structure temporary tower equipped with multiple hoist lines and connecting platforms on each floor to supply construction materials, semi-finished products, and workforce to the main building under construction. At this time, the exterior of the building has the shape of writing brush that stands upright, and as the plane becomes smaller toward the upper floor, the gap between the building and the common tower increases toward the upper floor, which causes structural stability problem. So on the 76th floor, they join the hoist common tower and the bell truss. The common tower above the 76th floor has a transition structure that moves 9.1 meter in the direction of the main building. Thirdly, let's find out about the pumping of concrete. In pumping of concrete, proper mixing manufacturing of concrete is just as important as the pumping equipment. For this, Lotte has developed concrete that minimizes viscosity by reducing the amount of cement used to less than 1,000 kg per cubic meter and securing flowability using fine gravel. The concrete is casted by moving from concrete pump located on the ground to the pipe and to the CPB. According to the Lotte ENC, the time required to push concrete up to 500 meters with an ultra-high pressure pump is only 25 minutes to when constructing the Lotte Tower. It is 5 meters faster per minute than the high pressure pump used in general high-rise building. Lotte Tower used 4 high pressure pumps 7 high-pressure pipes, and 3 CPBs. At this time, CPB stands for Concrete Placing Boom and is a machinery for casting concrete in a desired position. It is mainly used when it is hard to access pump cars and when constructing high-rise buildings. The actual application process is as follows. The ramekin is put into the pumping station, then concrete injection, high pressure pipeline, and pipe frame. Pipeline, pipe frame, CPB. Then using CPB, concrete is casted. Finally, let's take a look at the process for more precise and safe construction of Lotte Tower. For precise construction, Lotte Tower calculate the correction amount considering building movement through at least 4 satellites simultaneously and 7 tilt-meter measurement that can check how much the building tilted to the left and right. This video can help understanding. The satellite measurement system, which called GNSS, measured the slope of building using principle of triangulation measurement. Finally, it is about safety construction. 6 safety measures have been prepared at Lotte Tower. First, ACS. Second, protection deck. Third, safety net. Fourth, safety fence. Fifth, risk detection sensor. And finally, there is a protection screen system. Among these, let's take a look at the protection screen that can directly ensure the safety of workers. In a general building, safety is ensured through guardrail and vertical safety cover. However, the work of skyscraper is much more affected by wind than by general buildings. So it is dangerous that install only guardrail. And it cannot cover the entire high building, and it is inefficient because it must be installed and dismantled by hand to cover only a part, not an entire building. Therefore, Lotte Tower introduced the following protection screen. Basically, it acts like a shield for workers working around slabs and slabs inside building. In addition, the protective floor is automatically raised when the working floor is changed by using a hydraulic machinery such as ACS. Then, let's take a look at the principle of the system. The system is structured as follows. The system basically covers the 3 floors, and the upper and lower floors are support floors, with anchors that fix the protection screen to the slab. The hydraulic cylinder is installed on the middle floor, and through this, the protection screen can move the work level by itself without installing or dismantling. Think of it like the one used in ACS. However, the system requires some sort of deformation. Since Lotte Tower has an atypical structure, the frame becomes narrower as it goes up. However, the basic form of this system is mainly used for fixed building, and since the screen itself is fixed as it goes up, it is impossible to fix the wall. Therefore, the protection screen was set to be adjusted according to the displacement and installed as the ACS automatically adjusts the deformation of the frame displacement. As it goes up, the following protection screen is used in buildings that do not have wall displacement. But the following protection screen is used for a tilted surface such as Lotte Tower. The difference between them is an anchor. The tiltover safety protection has the following chain hoist of anchor. It can adjust the tilt of the protection screen by pulling or pushing it toward the building. In this way, we studied 4 categories that divided into foundation, structure, lifted system, and precise and safety construction about Lotte Tower during this semester. This is our final presentation slot. Hyunmin and Inchang made a summary of all categories and PowerPoint. Yaring made the whole design of PowerPoint and wrote a Korean script. Youngjun and I wrote an English script and I made the presentation. Thank you for listening to everyone, and special thanks to Professor Jejun Kim. Thank you.